The application layer responsible for continuously loading nodes from the repository, in other words, watching the nodes, is implemented. Now it's time to get into the details of how to watch the nodes using Firestore's real-time capabilities. Hello, welcome to ResoCode, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. So yes, it's true. In this part, which is the 16th part of the domain-driven design Flutter series, we are finally going to start working with Firestore. We're going to implement the inode repository, but not all of it, only its first two methods, which as you can see are the watchAll and WatchUncompleted method. As I've said in the beginning, in the previous part, we have implemented the application layer, which means in our case, the blocks for watching all and watching uncompleted nodes. So now it's time to do the implementation when it comes to the repository. So where will the actual implementation of the repository live? Because the interface of it is present inside the domain layer, but its implementation fits right into the infrastructure layer. So let's create a new file under infrastructure nodes. It will be called node repository.dart. And just like that, we are going to create a node repository. I'm going to use a shortcut to create a class file, as I call it. So class node repository, and it will implement inode repository. So we have this interface here so that if we, for some reason, decide that we want to have a different implementation of a repository using some sort of a different service, we can just swap them out, but the repository, which is saying that we should be able to watch all, watch uncompleted, create, update, and delete, will remain unchanged. Now I understand that you are probably not going to be changing Firestore for some other service very often, and if you did, it would not even hurt to rewrite a bit of a logic. But the interface has a beautiful property, which is that you are just forced to program sort of into an interface, and the implementation therefore will come out of the interface. Because if you start building the implementation without an interface, without really thinking through that you should be able to watch all, watch uncompleted, create, update, delete at first, some bad code may come out of that process. But when you have an interface already in place without implementation, you have just these method definitions that just forces you to think about all of the possible possibilities, which are going to be doable through a repository or whatever other class you have as an interface at first. So because we have an interface here, we can hit Control dot or Command dot and create 5 missing overrides using VS Code. Yeah, that quite didn't work, which is unfortunate. The whole code is just a mess, so I'm going to probably... Oh, it did work. Okay, I just hit Control Z and now it works. Very weird behavior from VS Code, but hey, we have it here and it's all cool. We are not going to implement create, delete, and update in this part, so let's move the watch all and watch uncompleted methods to the top of the repository, because we are going to implement only them in this part. And while we are at it, we want to operate with Firestore inside of this repository. So we are going to create final Firestore, and let's import Firestore. We have already added it as a dependency in some of the previous parts. And just by the way, we are currently at the version of Firestore, which is 0.13.6. So make sure to follow along with the same precise version as I have here, 0.13.6. Okay, let's add this field to the constructor. And let's also make this repository into a lazy singleton. So add lazy singleton. We do it with the capital L because we want to register it under a different type. We want to register it under inode repository. So we're gonna say as inode repository. And this way, for example, from within our block, whenever we request a inode repository using the injectable package, we are going to receive our node repository, which is its implementation. Okay, that's why we are using the interface in the first place. Now, some of you may object that repository should not in itself depend on Firestore directly, but instead we should create some sort of a, we should have something like final node Firestore service, something like that, right? So we should create some other layer of abstraction on top of Firestore, and the repository would communicate with that. I am all for these kinds of like data services or data sources. For example, when you are operating with a regular REST API, which you need to cache yourself in a repository, I am all for having something like node remote service, and then having local service, which would communicate with a local database, for example, SQLite using Moore, or something like Sandbast or Hive, so node local service, local, and so on, right? So I'm all for it, but as you can see, it creates just another layer of abstraction. And when it comes to Firestore, which truly does everything for you, it even caches data locally whenever it seems fit, then it also is quite simple. It's not like you are calling some HTTP endpoints yourself. You really just call functions, which are Dart functions. They are easy to work with and they are expressive. They're not just some strings of addresses. So that's why when it comes to Firestore, especially in this series, I have decided that we are not going to have any such other layers of abstractions, and we are going to depend on Firestore directly inside the repository. Okay, so let's implement watch all, shall we? The structure under which we are going to store the individual nodes is that every user will have his own collection of nodes, and the actual structure of Firestore will be as follows. There will be one root collection called users. Then this users collection will hold user documents, and every user will have only one document, which will be identified by user ID. This user ID comes from Firebase auth, by the way. And then every user document will have collection of nodes, which will be identified by node ID. And then this individual node document will hold fields for the node body, and the to-dos which are contained inside the node will be represented by an array of to-do objects. Now that we know about the basic structure, we have to ask ourselves a question: how can we get to this nodes collection so that we can watch all of the documents, all of the nodes present inside this collection? we need to be able to navigate to users/user ID/notes. How can we do that? Well, of course, in order to get the user ID, which is the real culprit here, we need to obtain the authentication data of the currently signed in user. And how can we do that? Well, if you remember all the way back, we have implemented an auth facade. So let's check out the iAuth facade. Where is it? Auth domain, iAuth facade. Over here, we have a method called getSignedInUser. And this returns an option of user. And this user has a unique ID. And this iAuth facade's implementation, if we check it out by hitting Control or Command and F12, I guess it's the same on Mac, hopefully. If not, then find it yourself. This method is implemented that the user is, of course, the Firebase user, and therefore the ID is, of course, the Firebase ID which we need. So we, in other words, need to be able to call getSignedInUser from within our node repository to obtain this user ID in order to get to the proper collection of nodes. And by the way, this is not secure. We still don't have the security rules in place which prevent other users from accessing inappropriate user collections. We're going to come to that later. For now, we're just going to focus on the Dart code. Securing the Firestore backend will come later on. This is just because in tutorials, it's quite hard to just jump in between different stuff, in between windows. We want to really focus on this repository in this part. But if you are building the app yourself, it may be good to implement security rules as you go, because that way you are not going to forget about them. I already have them implemented, so I know that I'm not gonna forget about them, but you may forget, so just please implement them as you go in your own real-world projects. Since obtaining the user document represented by the user ID is quite a lengthy process, and we need to do it multiple times throughout this node repository, we are actually not going to write the code directly in here. We are instead going to create an extension function on the Firestore instance. So let's go to Infrastructure, Core, right-click, and we want to create a new file, Firestore helpers.dart. And inside of there, we are going to create an extension, Firestore X on Firestore. And in here, we want to create an extension method, which is going to give us a readily available user document. Or it's going to also throw an unrecoverable error. So we want to be able to get future, of course, because it's all asynchronous, and then document reference, which comes from Firestore. And we want to be able to get a user document, so let's name this method accordingly. It's going to be asynchronous. And how is it going to look like? Well, as I said, at first we want to get the signed in user. And we can do so from our auth facade. We want to call getSignedInUser. Now, we can do this completely fine, because if you have noticed, we are within the infrastructure layer. So this means that even though we are calling a different feature held inside the infrastructure layer, we are operating from within the core and calling code which is present inside the auth feature. This is all well and cool, because in the, let's say, design spec of DDD, which I have at least proposed for this particular tutorial series, nowhere in there is it said that you cannot call code which is from a different feature. All you cannot do is to break the layer structure. So this means that while calling the auth feature from within core is okay. What is not okay is calling domain from infrastructure. That's not cool. Okay, that's just for some of you purists out there. I know that you are out there watching this video. So with this purism out of the way, let's call the getSignInUser on iAuth facade. Because we are using getIt and actually injectable for dependency injection, obtaining the iAuth facade instance is absolutely simple. All we need to do is call getIt iAuth facade. Because iAuth facade is a lazy singleton, we are going to receive the one and only instance which is present in our app, which is awesome. And getSignInUser should be called on it. Now this is asynchronous, so we want to await it and put the result of this call into final user option. Okay, we'll make it equal to that. And now we want to extract the actual user from this user option. And in case that there is no user currently signed in, we want to unrecoverably crash the app. We want to throw an error which will never be caught by our code. We are doing this because if we get to this point inside our app, we call this user document extension, which means that we want to obtain the user document, but no user is currently signed in. That means that we have a huge problem taking place right now, because it should be impossible to get to a point where we request a user document and the user is not signed in. That's because by the design of our app, we sign in the user before trying to obtain the user document. If the design of your app is different, you would handle this case when the user is not signed in differently, possibly offer the user an option to sign in, right? But in our case, we are not going to offer the user any kind of a dialogue saying, hey, sign in before you can do this action. We're just going to crash the app because that's what our design spec says. So while we want to retrieve a user, finally user stored inside this variable, we want to obtain it from user option by saying get or else, and this or else clause will just throw some sort of an error, which we actually need to create right now. We are storing all of our errors inside the domain layer, core errors. We already have an unexpected value error, which also just crashes the app. All of the errors are just for crashing the app in case something really horrible happens. And this one will be called not authenticated error. Again, if you had a different design spec, you would show some sort of a dialog to sign in if you so desire. So it's going to extend error, and this will be just a very plain class. It's not going to have any implementation of its own. So now we want to throw this not authenticated error from here, instantiate it and import it to here. And lastly, if no error has been thrown and we have the user instance readily available, we want to return from this extension method Firestore instance collection users. Okay, we are getting to it, and then document. And if you remember, every user document is registered under its owner's ID. So we will say user ID, and then again, if the ID is not available, something has gone horribly wrong. So we want to get or crash with this unique ID value object. While we are here inside Firestore helpers creating these kinds of extensions, let's also create another extension, which will be a document reference extension. So it will be extension document reference X on document reference. And this will simply define an extension for getting the notes collection. Usually, if you want to get a collection of something, you do it like this: dot collection and specify its name. So we could say something like dot collection on the document, of course, dot collection notes, right? And this would give us users slash document ID, which is the user ID, slash notes collection, just as I have written out in the note repository. But specifying always the notes string is not necessarily good practice because, hey, it's a string. We should at least provide some sort of a notes constant string, right? Some sort of a constant. But again, we can do it better. We can create an extension so that we will be able to just call something like note collection, which is going to give us the collection of notes without putting in any kind of a string or a constant string. Okay, so let's create such an extension right now. It's going to return collection reference. Get, it will be get only property, note collection. And it's going to return collection notes. Awesome. All right, so we have all of the extensions in place, user document extension and also note collection extension. So let's come to the note repository. And since unfortunately extensions cannot be automatically imported, we need to copy this extension's path. So this Firestore helpers, let's right click on that, and we want to copy relative path. Now paste it into our note repository, put it into these quotation marks. Okay, instead of lib, we're going to say package notes Firebase DDD course. All right, and slash, and then change all of the backslashes to be forward slashes like this, and let's say import. Oops, like that. Now we are talking, we can use these extensions from our code base. So let's first tackle the watch all method, right? Because it's simpler. We do not need to filter anything. We can just watch all, as it says in the name, all of the notes. So in order to get the user document, we're going to simply say Firestore dot user document. We are using our own extension. And let's actually put this into final user doc. Okay, and let's make it be awaited because it's asynchronous. And let's make this method asynchronous, but not just regular asynchronous, but instead an asynchronous generator. Because as you can notice, we are not going to return a simple future from this method, but instead a stream. And we are going to do it in a way where we are going to utilize asynchronous generation, which is a very cool feature which Dart offers. We want to observe or watch all of the notes. They are present inside the user document in the note collection. Again, we are using our own extensions here. And collections offer the snapshots method, which is going to return a stream of query snapshot, and this will notify our code whenever some new note is added to the backend. This is the real-time functionality of Firestore, and it's absolutely awesome. And actually, it can result in even lower cost of using Firestore because these snapshot observers of the collections are actually optimized for cost. They do not just push the whole collection, which would have many document reads basically built to your account. But if only one document changes in the collection, only that one document update is sent over the network. So you pay only for that one document, not for the whole collection at all times, constantly, right? So it's really optimized. If you can use real-time data like this, where you observe it as a stream, you should absolutely do so. It's definitely much better and also cheaper, therefore, than just calling node collection get documents, because this would get all of the documents at all times. You do not want to do that. Instead, use Snapshots, which returns a stream whenever you can. It's going to be cheaper. Okay, but now these snapshots are nowhere near our wanted type, which is either a node failure or a KT-list node. These snapshots hold something called a query snapshot, which is an absolute low-level type coming from Firestore, and we need to extract our data from it and transform it into our own types. Before we do so, though, these snapshots are not really ordered in any way, but we want to order our nodes descendingly based on the time of their latest update. And if you remember, if we check out the node DTOs, we are indeed storing a server timestamp field inside our node on Firestore. It's implemented as a Firestore field value, which is a, how is it called? Sentinel value, that's right. It's a Sentinel value which is only populated in Firestore, but regardless of how it's implemented, we should know that we have a server timestamp field on our documents representing nodes inside Firestore. So we can actually order the nodes by this server timestamp. So let's do just that. We're going to copy the server timestamp name, and before calling snapshots on node collection, we want to create a query, and we want to order the documents by nothing else than server timestamp, and we want it to be descending, so descending true. Awesome, right? And of course, because we should return a stream from this method, let's actually yield each thing which comes through this query snapshot stream. Of course, we cannot, again, return query snapshots directly. We need to map them to either a node failure or a immutable Kotlin list of nodes. So let's do just that. We are going to say map on the stream. We're going to rename event to snapshot to be more explainable. And let's talk about how errors are handled in streams by default when it comes to Dart. The way that errors are handled is nowhere near as awesome as we are doing it with either type. By default, streams errors are handled very similarly to how, for example, regular exceptions are passed around in Dart. Usually you handle your errors, unless you are a fan of the either type, of the functional way of handling errors, then you would probably handle errors coming from a stream in a way that only when you listen to the stream, then you can have a OnError function and perform something in this function, right? Error, and display something to the user, some sort of an error snack bar or something. You would do this from the bottommost layer, from, I don't know, from application layer, let's say, or from the presentation layer. So this is very similar to what you have with the try catch blocks. You need to remember, you need to absolutely remember yourself that there is a possibility of an error, and you need to catch it yourself, and you need to handle it yourself without any sort of a help from the compiler. And I say, if we have the compiler, why not use it to the full extent in a way that it's going to help us with catching and handling, which is the most important part, of errors. So on this listen function, you can see that the flow of the good, the correct data, is separated from the bad, the erroneous data. And this also means that when it comes to functions like map, they are not going to receive the errorful data, or however you want to call it. This query snapshot is always going to be just query snapshot. It's not going to be the exception, which can possibly happen on Firestore, for example, when we don't have sufficient permissions to view some document. And because this map function always receives only the correct data, we can always return the right side of either from here. So right, which is going to contain the snapshot dot documents, which is a list of document snapshots. And we want to map this list of document snapshots into a KT list of notes. So we are going to say map and map each and every document snapshot called doc to a note DTO at first from Firestore. Let's import node DTO actually from Firestore doc. And now once we have this node DTO mapped from Firestore, now we want to map this node DTO to domain, which is the node type, right? And then this just returns an iterable, and we want to map even this iterable to immutable list, which actually comes from the KT Dart extension. For some reason it doesn't want to appear here. Okay, this is interesting. We have imported the KT Dart /src, but we should actually import something completely different for the KT Dart library. So let's remove this import from up top here, and let's try again to import KT list. And now we want to import it from KT Dart /kt.dart. And this will allow us to use the toImmutableList extension method like that. Let's put a comma in here and we are all golden. Cool. So we are returning only the right side of either from the map function, because the map function will only receive the correct data, which in our case we represent it as right side of either. But what about the left side of either? How can we catch the exceptions passing through the stream and transform them into something which is the left side of either, in our case, into node failures? Well, the easiest way to do it is with RxDart, which is basically an extension, now truly an extension on top of regular Dart streams. With RxDart, we are going to be able to call something called OnErrorReturnWith. As I said, in order to be able to use this method, we need to be able to use RxDart. So let's go over to pubspec YAML, and we're going to say pubspec assist add update dependency rx_dart. Actually, no underscore. Okay. Currently, it's at the version 0.24.1. So make sure to use this one. And now we are going to be able to use OnErrorReturnWith. But again, because it's an extension method and extensions are just not being able to be imported easily as of now, we need to import the RxDart library ourselves. So we're going to say package :rxdart/rxdart.dart. Awesome. Now, as you can see, we currently have the OnErrorReturnWith method available, which is an extension on top of a regular stream. And this accepts the exception E or error E, however you want to call it, although I prefer exception because as I use the nomenclature, extensions can be caught and errors are basically a subtype of extensions which are never caught. Errors are for crashing the app, while extensions are for telling something to other layers of the app, but we don't use even extensions. And if I set extensions instead of exceptions in the previous minute or two, then of course I meant exceptions all along, of course. Not extensions, but exceptions. So what do we want to do from here? Well, we want to check the now currently dynamic exception type. If it is, so if E is platform exception, which is the exception which comes out from Firebase snapshots, the documentation on this exception type is really poor. I had to search through it for quite a long time when I first started out with Firestore and Flutter. I mean, they could really improve the documentation, so I'm not really able to show you all of the exception codes because even I don't know them. It's really an unfortunate situation that we are in. But basically, if the exception is of type platform exception and its message, so e.message, contains permission denied, which is a string, permission denied, this means that the user or we in the app have tried to access a document which is protected by the security rules to not be accessed by this particular user. And of course, it wouldn't hurt if we provided an AND operator here, of course. So now we are talking. And for some reason, this E is not getting smartcasted to a platform exception, but we know that if this condition passes, then E is, of course, of type platform exception, so we can access its message just fine without any problems. So in the case of this, when the permission has been denied, and that's why we have gotten an exception, then we want to return left, and we want to return a node failure, which we currently don't have because we have only unexpected failure present on the node failure union. But of course, this case is not unexpected. This is a known case, which we should handle accordingly. So whenever permission is denied, we should return something like insufficient permissions failure. So let's come to the failure union by hitting F12. And in addition to unexpected, we are going to also create insufficient permissions. Let's also rename the class name insufficient permissions. Okay, and let's run our favorite command, which is going to be in the video description too, flutter pub run build runner watch delete conflicting outputs to generate this union case. And while this is running, we can go to the node repository and say insufficient permissions, that's it, and also add the constant modifier over here. And otherwise, if there is some other exception happening, or if the message does not contain permission denied, then it's the perfect case to return the unexpected node failure from this OnErrorReturnWith method. And also, I would recommend you to log the unexpected exceptions. So something like log error E to string, something like that, right? Or maybe lock error. I will just leave this comment in here to signify that you should probably log unexpected exceptions and send them somewhere, at least while you are in debug mode, of course. But we are not going to do that. We're not going to log anything to make this code a little bit more simple. We have this watch all method right now fully implemented, but as you can see, we are getting some errors here saying that the type stream either dynamic KTList node, implied by the yield expression, must be assignable to stream either node failure KTList node. So somewhere along the way, we have lost the type information for the left side of either. It should be node failure, but currently it's dynamic. So what can we do? I mean, this behavior is really unfortunate. It's an insufficiency in type inference when it comes to Dart, but we can fix it pretty easily by just providing the generic type explicitly for this write function. So we can specify the L and R generic types ourselves, which is going to make the code base a bit more clunky, but hey, it needs to be done, so we cannot complain. The left side is of course node failure, and the right side is KTList node. If we put it here, now as you can see, the error has gone away and everything is cool. Now we want to implement WatchUncompleted, and this is going to be totally simple to do. We are just going to copy the watchAll method implementation and paste it into WatchUncompleted. And of course, we could extract a bit of code here and there into its own method, but in the case of these two methods, it would actually create more confusion than good things. So that's why we are actually going for code duplication. It's not that horrible in this case, I would say. So again, this should be an async generator like that. And the only change in the WatchUncompleted compared to WatchAll is going to be in the map function, of course, because think about it. What do we want to do inside WatchUncompleted? Well, we want to check if the to-dos are all completed, and if they are, we do now want to show them in the output stream. So for example, if I show you here, you can see that this red node has all of its to-dos completed. Read Plato's Republic, learn about Socrates. And because it has everything completed, we want to filter it out whenever we want to watch only uncompleted things from here, okay? Like that. And yes, we are doing this filtering client side, not server side. In this case, it's completely cool, but if you have some other use case where you want to switch between things like, for example, ordering or something, you would actually want to order it or filter it on the server side. But here, again, we are going to filter and do everything on the client side inside this map function. Actually, to make this filtering process of only uncompleted nodes a bit simpler to understand, we are going to create another map function, so chain it after the first one. Because we have this second mapping function, this is where the filtering of the uncompleted nodes and also their conversion to either node failure or KTList node is going to take place. This first mapping function will now be only a simple conversion between the low-level document snapshots and node DTOs, or actually node domain entities. So we're going to remove the write node failure KTList function, and also two immutable lists will be removed from here. So all that's left here is the mapping of the document snapshots from document snapshots to node entities. And now all of the magic will be moved to this second map function. So again, we want to return from here write node failure kt list. Let's rename the parameter to nodes. So this will be returned from here. And these nodes are an iterable holding node. And we want to say nodes and filter them, which is done with the where method on an iterable. And we want to only have nodes in this stream of uncompleted nodes, which are of course uncompleted. So we're going to say where nodes dot to-dos, because we are inside an entity, we need to get or crash, and we will say any of the to-dos is not done. So to-do item dot done, and negate this thing. And then say to immutable list. Awesome, like that. So again, in this first map function, we just map the document snapshots to node entities, which are then passed over to the second map function as an iterable of nodes. And from here, we return only the right side of iter, because again, map is never going to receive the incorrect values, the failures. And since we want to return only the uncompleted, or actually yield only the uncompleted nodes, we need to filter them on the client side. So we say we want to have only nodes where the nodes to-dos has any, which means has at least one not done to do. And then of course we want to get it in the format of kt list, so we say to immutable list. And the rest, the error handling, can stay the same. And just like that, we have implemented the watch all and watch uncompleted. And I understand that especially this second part may have been a bit exhausting with all of this filtering. So as always, you can get the code from the link in the video description. Of course, you can also rewatch the parts which were your sticking points. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, link is also in the video description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you do not want to miss more tutorials like this from the domain-driven design series and also other Flutter tutorials, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you with operating with the real-time data coming from Firestore and then mapping it accordingly to your own classes, give this video a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.